This is part 4 of section 2.6. If we have an odd degree polynomial and it has real zeros, then every polynomial with odd degree has an odd number of solutions, and therefore it has to have at least one real zero. And why is that? Because complex solutions always occur in pairs. And it doesn't matter how many complex solutions you have. Once you take all of those out, you're going to have at least one solution left that is not complex because it is odd. Now, if it's an even degree, they could all be complex. Just something to keep in mind. And here, the factorization theorem for a polynomial with real coefficients. It says every polynomial with real coefficients can be uniquely factored over the real numbers as a product of linear factors and or irreducible quadratic factors. Now, what do they mean by the irreducible quadratic factors? That's like what we had right here when we multiplied out the complex answers, when we got that part right there. That's what we're talking about. The part that cannot factor any further, and to solve it, we would need to go to the quadratic formula. Okay, so let's look at a problem. Find the polynomial p of x that has real coefficients and is of degree 4, has a leading coefficient of -3, and two of my zeros are 2 plus 3i and 1 minus 4i. Okay, so one of my solutions will be 2 minus 3i, and the other solution would be 1 plus 4i. Okay, so my p of x is always your leading coefficient, -3, times, it's going to be x minus this times x minus this. Well, we can go and use the formula we had on the previous page. If I'm multiplying this with these two solutions, my a value is 2, my b value is 3, and I need a squared, which is 4, and b squared, which is 9. Okay, so if I am multiplying the two factors involving these, I get x squared minus 2 times a, so 2 times 2 is 4, x plus a squared plus b squared, which is 13. Okay, and then we're going to do the same thing here. Here my a value is 1, my b value is 4. I need a squared and b squared. Okay, so this factor would be x squared minus 2 times a, which is just 2x, plus a squared plus b squared, which is 17. Okay, and this would be, each of these is an irreducible quadratic. Okay, now if they need you to multiply everything out here, it's just a big FOIL problem. Just be careful with your signs and your arithmetic. I know you're not going to have any trouble getting that done. In fact, if you want to, I have the answer written down here just to check yourself. The answer all multiplied out would be -3x to the 4th plus 18x cubed minus 114x squared plus 282x minus 663. Okay. So on this problem, we were given enough information to very quickly find all 4 solutions. Because I needed to have 4 solutions, we were given 2 different complex solutions so we could find the remaining 2 easily. Here, we don't have that as much. We want to use the given 0 to find all zeros. Okay, well, if 1 0 is 1 minus I. The other one will be 1 plus I. Okay? And that means that part of the factorization of this thing will be x minus this times x minus this, in which case we can use the formula we've been doing, where a and b are both 1. So one thing I do know is that x squared minus 2 times a, x, plus a squared plus b squared, which will be 1 plus 1, x squared minus 2x plus 2 is a factor of this thing, okay? Now, it's times something here, and I need to find that other something. Well, if you know one part of a multiplication and you have the answer, you could find this part by doing a division. So I'm going to do long division here. X squared minus 2x plus 2 divided into x to the 4th minus 2x cubed plus x squared plus 2x minus 2. Okay, so x squared needs to become x to the 4th, so I need to multiply that by an x squared. Distribute the x squared through here. Okay, change your signs and add them together. That cancels, and so does that. So I have negative x squared, and I'm bringing down the 2x and the minus 2. So if I need the x squared to be negative x squared, I need to multiply that by a negative 1. Distribute. Okay, and then when you change your signs, everything cancels out as it should because this was supposed to divide in evenly. So what I now know is that I have this as part of my factorization, and x squared minus 1 is the second part. This factors further to x plus 1, x minus 1. So here we have two of our solutions, and from here I get negative 1, and here I get positive 1. So the four solutions we have here are negative 1, positive 1, 1 minus I, and 1 plus I. Okay. We're doing the same type of problem here, except this is going to be longer. Okay. We are given one solution, and it is a 5th degree equation. So we're going to have to do a lot going on here. I know one of my solutions, and it's complex, so I know the second one. Okay, so I'm going to need to do a long division here involving these two factors, and we can use the formula we've been using here to find the irreducible quadratic. If we have I and negative I, our A value is 0, and our B value is 1. So I know one of my factors is x squared minus 2 times 0, which is 0, so that whole term goes away here, plus a squared plus b squared, that's simply a 1. Okay, so I've got that. So I need to divide this by this to see what I have left. So remember to put your 0 back in here. X squared plus 0x plus 1 divided into 2x to the 5th minus 11x to the 4th plus 19x cubed minus 17x squared plus 17x minus 6. I didn't leave myself a whole lot of room there. Okay, well, if I want x squared to become 2x to the 5th, I need to multiply it by a 2x cubed. And distribute. Okay. Change all the signs and then add to get negative 11x to the fourth plus 17x cubed. Bring down the rest, minus 17x squared plus 17x minus 6. Okay, now I want x squared to become negative x to the fourth, so I need to multiply that by a negative 11x squared. Distribute this through here. Negative 11x to the fourth plus 0x cubed minus 11x squared. Change your signs and add for 17x cubed minus 6x squared, and then bring down the 17x and the minus 6. To make x squared into 17x cubed, I need to multiply by a positive 17x. Distribute here. I left off the x there, plus 17x. Okay, change your signs. And add, and we get negative 6x squared plus 0x, bring down the minus 6. And then finally, I need a negative 6 here. And then when we change our signs and add, we get the 0. Okay, so I expect 5 solutions. I've got 2 of them so far. I have negative I. Now I need to set this equal to 0 and solve it. Okay, so my new equation to solve is 2x cubed minus 11x squared plus 17x minus 6 equals 0. I do a quick glance at it to see if I can see how it factors maybe by grouping or something else, and I don't see anything here. So we need to do the P over Q thing. We need to decide how many positive answers we might have, and so on. Okay, so my p-values are going to come from 6. 1, 2, 3, and 6. My Q values come from the 2. Okay, so my P over Q possibilities are 1, 1/2, 2, plus or minus 2, and then 2 over 2 is 1, which is already listed, and then 3 over 1, 3 over 2, 6, and then 6 over 2 is 3, which is already listed. Okay, so let's do the number of positive solutions we can expect. How many sign changes do we have here? 1, 2, 3. So I have 3 or 1. And if I look for the number of negative sign changes, without writing it all out, if I do f of negative x, that changes the signs on my negative exponents. So I'll have a negative, a negative, a negative, and a negative, which is no sign changes. So there's no reason for me to test any of the negative possibilities. So I'm just going to pick one. I'm going to start with 1/2. And use these coefficients. Okay. And bring down the 2. Multiply to get a 1. Add negative 10. Multiply to negative 5. Add to 12. Gives me positive 6, which gives me a 0 from the very beginning. So I know that 1/2 is another one of my solutions. Okay. Now this will be a quadratic. It is 2x squared minus 10x plus 12 equals 0. I can divide everything here by a 2 to make my life easier. Okay, and then this factors with a negative 2 and a negative 3. So my other two answers are 2 and positive 3.